Welcome to Conceptual Physics. My name's Brother Matt, and you are watching The Physics Friar. In this introductory series, we are going to be talking about science in general, and we're going to be discussing the following topics: what science is, the importance of scientific measurements in science, how science uses the language of mathematics, scientific methods, and most importantly, I think, the scientific attitude. Now, we're not going to cover all of these topics in one video. We'll actually break this up into 3 different videos, and this particular episode will cover the first 2 of those topics, or rather, really topics 1 and 3. What science is, and mathematics as the language of science. And we'll deal with scientific measurements more in the second episode of this series. So, what is science? Well, I think probably most people in high school, and maybe even most people, think of science as what's in books. It's a body of knowledge, and to some extent that is accurate. Science is this pile of facts, okay? Science. That's enough to make one stop studying it, especially if you have to memorize all of this information, all of that stuff, that body of knowledge in textbooks. But there's a much better, much more accurate definition of science, and that is that science is an ongoing human activity. Specifically, it is what happens when a person asks, "How does that work?" Or, it's kind of funny. You see, science is actually much more than a pile of books or a body of knowledge. Rather, it's much more accurate to describe science as the activity that happens when you ask, why? How does that happen? That's kind of funny. Let me study that a little bit more. And as long as people have been asking questions like how and why and how does that happen, people have been doing science. See, science is the activity, the process of answering those questions, as opposed to, memorizing facts from a book. Science is a doing. You do science when you study different things like, say, this amazingly balanced bird. And so really, science is as old as the human race. As long as we've been around, we've been doing science when we've been asking questions like how and why. Now, good science always involves exact measurements, or as exact as you can make them, right? You can wonder how this is balanced, which is one thing, which is scientific enough, but then you can also go about, if I can figure out this meter stick, then you can also go about actually making some measurements to do some better science than just wondering. Now, I really like this quote about measurement from Lord Kelvin, and I think it really illustrates, it brings the point home. Now, I have to read it in a British accent because Lord Kelvin was British. So, Lord Kelvin said this: "I often say that when you can measure something and express it in numbers, you know something about it. When you cannot measure it, when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. It may be the beginning of knowledge, but you have scarcely in your thoughts advanced to the stage of science, whatever it may be." So, you see that it's measurements that are the hallmark of good science. Measurements are what separate science from just sitting in your chair and wondering. All scientists also speak their own particular language. I bet you didn't know that there was a science language. And the good news is that you've already started to learn it. The language of science is math. Now, why do scientists use math? I think the most important, for me anyways, the most important reason that scientists use math is the second one here, that the ideas of science are unambiguous when they are expressed in mathematical terms. Now, what that means is basically this. When scientists speak math, they are speaking very clearly. They are saying exactly what they mean. Perhaps you've been frustrated by a relationship that you've been in, and when relationships break down, often one person says something and the other person has absolutely no idea what the first person is saying. That's a problem with everyday language. It's confusing sometimes. It's ambiguous. You can say something, it can mean two things at the same time. Well, math is a language that has no ambiguity. It means exactly one thing. For example, and we'll be learning this, Newton's second law states that the force on an object is equal to the mass of the object times the acceleration of that object, which is quite a mouthful. I could say that, I could write it down, or I could just show you the equation. F equals m times a. It's much simpler and it's much clearer when written this way using the language of mathematics. Scientific equations express relationships as well, but unlike human relationships, the equations of science provide very clear expressions of what the relationship is between different concepts. This relationship here is pretty unambiguous. The force always knows what the acceleration is doing, and vice versa. Right? No relationship problems whatsoever. Finally, scientists use mathematical equations to guide their thinking, to make predictions. Let's take this example again. We can use equations like this to guide our thinking, to make predictions. Let's say you have a certain object, an eraser, right? This is the eraser. It has a certain mass, and that mass is not going to change. Let's say you have an acceleration on it, and you double the acceleration. What do you think is going to happen to the force? It's also going to double. The equation can allow us to make a prediction, which then we can actually test in the lab by making good measurements. So to sum everything up, science is not necessarily, it's much more than a body of knowledge, textbooks. Rather, it's a process that starts with the question, that's kind of interesting. Let me try and make a guess about the relationship between this interesting thing and some other interesting thing, and let me express that guess in a mathematical sentence. Once you have that mathematical guess written down, then you can test it with an experiment with good measurements in the laboratory. That's science.